So have you had any reactions from people as you ride this weird looking thing around the city?
Yes, I have. I've been asked if I'm spying. I've been asked if I'm NASA. A lot of people are really curious and friendly. They do approach me and ask what it is. I tell them exactly how I explained it to you. It's the temperature bike. I'm just measuring air temperature. I'm not listening to anyone.
I'm here in downtown Montreal with Johanna Arnett. She's a master's student in urban ecology at Concordia University. She's part of a growing field, scientists investigating how a city's structures can affect the temperatures we feel. To get as much detail as possible, she's transformed her bicycle into a portable temperature sensor. Interesting looking bike you have here. I noticed that it has a bell on the front.
Yes.
But there's all kinds of other bells and whistles on the back. What's going on
There
here?
are, yeah. So this is a mobile temperature sensor for study on urban heat islands and the interurban variations in temperature.
Okay.
So
Now I noticed that it's got a white thing on the top of a tower here. You got this triangular tower. It looks like a bunch of saucers that have been piled up. What's that?
Yeah, so inside these saucer-looking things is a temperature probe measuring the ambient air temperature.
Okay.
It's mounted at 1.50 meters, which is more realistic for human comfort.
It's about eye level to me. Yeah.
Yeah.
Okay.
Exactly.
All right. And then there's a white cylinder halfway down here.
Yes.
What's that?
That's an infrared radiometer, which is for surface temperature. So it's measuring temperature of the surface behind the bike.
Oh, it's looking down at the ground.
Yes.
Okay. And then we got a green box with Garmin written on the top of it.
Yes. So the Garmin is the GPS to put all the data together, localize it for spatial analysis, and inside the box is all the wires, the data logger, the battery, putting it all together.
So how do you actually use this when you're measuring temperatures?
So I have 5 routes planned around the city that I bike multiple times during the day, the hottest part of the day, as well as during the night, 3 hours after sunset. And this takes a measurement every 1 second, which ends up being every couple of meters, depending on how fast you're biking. And yeah, for every point, I have all this data: air temperature, surface temperature, the solar radiation.
Okay. Is this on right now?
Yes, it is.
It is. So can I collect some data? Can I go for a ride and
Yes,
actually collect some real data in Montreal? Oh, goody. I'm part of a scientific project. This is great. I feel like a real scientist here. Here we go. It's a little shaky on the steering
Yes.
with all the weight on the back. I take off down a side street and then merge onto a busy road. Am I allowed to ride here? Oh, we're right here anyway. It's a familiar picture in cities in Canada. Asphalt on the road, concrete sidewalks, and glass buildings towering above me. Then I get to a park, and I instantly feel the difference. Under the trees, it does feel cooler. More than half the world's population lives in cities, and that's expected to rise to 70% by the year 2050. Here in Canada, more than 80% of us live in an urban environment. That's not just including the big metropolises like Toronto, Vancouver, and Montreal, but also the smaller municipalities across the country like East Gwillimbury, Ontario, whose population, according to Stats Can, has increased 44% in just 5 years. People look at you very strangely if you're riding around on this thing. It's very
Especially at
strange.
night.
I'm sure, yeah, like you're some kind of alien invader or something like that. That was fun. Johanna works in the lab of Dr. Carly Zeter. She's an urban ecologist and associate professor at Concordia University. Hello, and thanks for letting me ride your bike.
You're very welcome. Glad you enjoyed it.
Why are you researchers using bicycles to map out hotspots in Montreal?
So urban heat is a huge challenge for today's cities, and we know it's going to become more of a challenge with climate change. Now, many studies have focused on differences, between the city as a whole and surrounding areas. But we know that temperature can really vary hugely within the city itself. A green, leafy neighborhood might be several degrees cooler than a dense neighborhood, lots of buildings, low tree cover. So a bike lets us be really agile in terms of our measurements, get in and out of small spaces within the city to really understand air temperature at the kinds of scales where people live and work and play.
But why a bicycle? Can't we get information from satellites?
We absolutely can, and that information is really helpful. But what satellites are measuring is the surface temperature. And that's a little bit different than what we actually feel. So what we're trying to do is understand air temperatures. So closer to what people feel, closer to the kinds of temperatures that might, make us uncomfortable, make us sick. And so a bike gives us an additional layer of information because we have that air temperature. And it also lets us go out in different times of the day. A satellite might only pass at a very particular time. And we know that the impacts of heat can be really different depending on when we're measuring it.
But why is urban heat important to study in such fine detail?
One of the reasons we want to understand urban heat in fine detail is because those are the kinds of scales that people can really make a difference. So often when we're trying to mitigate urban heat, when we're trying to reduce urban heat, we're focusing on interventions like tree planting, like changing the vegetation at a fine scale. And without understanding the impact of those actions, it's really hard to improve them. So understanding the fine scale pattern lets us understand how we can intervene, as individuals, as city decision makers.
Wow.
One of the things Johanna is trying to understand now is in these dense neighborhoods, how much of a difference can we make by adding, a few trees here and there? So an even smaller intervention. And that's something we don't have as good of a handle on yet.
Out on the streets of Montreal, Johanna Arnett and I go through the data from my bike ride. So show me some of your data points here along this route that you followed.
Yeah, so between here, where you can see it's dark blue, that is 28.79 degrees. It's a hot day. And then here, it was 30.88.
Wow, and that's only a few blocks away.
Exactly.
Right. Now, what about the difference? One of your sensors looks at the ground temperature. What's the difference between the ground temperature and the air temperature?
Yeah, so here's a map where you can see the surface temperature. There's a lot more variation from even like a few meters to another. The interesting part is how much hotter the surface can be than the air. So for example, here the air temperature was 30.66 degrees and then the surface temperature was 47.38.
Wow, wow. 2 degrees air temperature might not sound like much, but as Johanna's colleague Bella Richmond, a PhD student in Dr. Zeter's lab, explains, it actually makes a huge difference to how the human body reacts.
And I think when we think about what we notice and what we feel when we walk from a street that has a lot of canopy cover, a lot of trees, where you can tell when in summer everyone's on the same side of the street because that's where all the shade is, because we're naturally drawn to that. But then when you walk to the next block where there's no street cover or very little, you can instantly feel that effect. And that air temperature difference might be 3-4 degrees, but you're sweating, you're thirsty, you're looking for a cafe to get an iced coffee. These are things that are happening with only a few degrees difference, which is to the human body a huge temperature difference.
This isn't just a problem for southern cities, it's affecting cities across the country, in the north as well. Another person trying to study this is University of Alberta urban planner Dr. Sandeep Agrawal.
Cities are hotter in general, wherever they may be. And the question that popped in our head was, is urban heat island an effect here within the city of Edmonton?
Unsurprisingly, he found that even a city like Edmonton is still much warmer than the green spaces around it. His research is showing that urban heat can affect any built-up environment where concrete is king.
In Edmonton, we found that urban heat island effect was quite prominent, especially during the summertime. In some parts of the city, we saw an increase of temperature up to 6 to 12 degrees compared to the rural surroundings.
He extended his research to other parts of Canada's north, and sure enough, the urban heat effect was showing up there too.
We have looked at Yellowknife and large parts of Northwest Territories in general, And we do find higher temperature in some of these small urban communities across the Northwest Territories. It's partly because of the rise in temperature globally, which is affecting the northern part of Canada much more, along with the surfaces, the types of surfaces being used in the communities, asphalt and concrete.
The urban heat effect exists because of a complicated mix of physics and environmental science. Dr. James Boot has been studying these factors for more than 30 years. He's a professor in the Department of Geography and Environment at Western University. Hello and welcome to our program.
Thanks for having me.
Now, you've been researching urban heat for a long time. Why is it so interesting to you?
I think urban heat is one of the important microclimates that affect a lot of people, and with the urban population now being the majority of the world's population, trying to understand the climate of cities is really important, and heat is one of the basic elements of climate.
Now, when you say microclimates, what do you mean by that?
We mean the very small scale from meters up to, say, hundreds of meters variation of the atmospheric parameters that are in cities. So anything that we consider to be climate, we can look at on very small scales, and the variability of structure and materials and the built environment in cities creates a lot of different microclimates in close proximity to one another.
So that's what you feel when you, say, step into a sunny area, then into a park? You feel the temperature difference, that kind of thing?
That's exactly right.
Well, take me through what we know about why the urban heat effect even exists.
So the story with urban heat starts with the changes to the cover, the materials that we have in cities. So you typically are replacing natural materials with built materials, and those built materials have different properties, what we would like to call the urban fabric. Those materials that we put into cities typically are a bit better at absorbing sunlight, and they're often quite a bit better at storing heat. And then as part of building cities, we're also changing the three-dimensional form of the surface. So we go from something that's typically more flat and homogeneous to something that's got a lot more three-dimensionality to it. So we increase the total active area that can absorb radiation. We create this geometry that allows sunlight to be trapped between buildings, and it also reduces the loss of radiation heat at night. And the third thing we do is we add heat to that atmosphere. So through our use of energy, through transportation, through heating and cooling our buildings, we're adding a source of heat to the city.
Well, those microclimates in the cities, then, how do they affect the overall climate of the air passing over